Secrets rarely make the status page, but they are the quiet power behind almost everything your systems do. When a new application goes live and starts talking to cloud databases, third-party APIs, and internal services, it does that work through API keys, tokens, and passwords. If those secrets leak into logs, chat, or public code, the jump from a small configuration mistake to a serious compromise can be very fast. This narrated edition of my Tuesday Insights feature from Bare Metal Cyber Magazine is all about treating those secrets as first-class assets instead of background noise. Secrets management for API keys, tokens, and passwords is the discipline that controls how sensitive credentials are stored, used, rotated, and audited. Think of it as a combination of tools, process, and culture. The tools give you a safer home for the values themselves. The process defines who can request them, under what conditions, and how long they remain valid. The culture shows up in the everyday habits of developers, operators, and security teams when they decide where to put a key, how to share it, and how quickly they react if something looks wrong. Most modern secrets management setups revolve around a secure storage system, often called a vault. That vault encrypts secrets at rest, exposes them only over secure channels, and enforces access policies that say which human or machine identities can read or update each item. Around that core, you have patterns for how applications retrieve secrets at runtime, rules for how long a key or password should live, and workflows for rotation and revocation. Secrets management lives at the intersections between development and operations, between infrastructure and cloud platforms, and between security teams and the business itself. It is equally important to be clear about what secrets management is not. It is not just turning on encryption for a configuration file and hoping for the best. It is not the browser password manager that end users rely on, helpful as those can be. It is also not limited to scanning repositories after a leak and rotating a few keys once the damage is already done. Instead, secrets management aims to prevent hard-coded credentials in the first place, centralize how new secrets are created and distributed, and make sure that every use of a secret can be traced back to a specific identity and purpose. It complements your identity and access systems by focusing on the credentials those identities use behind the scenes. In day-to-day operation, a typical flow starts with an application or service that needs to talk to something else. That might be a microservice connecting to a database, a background job calling an external API, or an automation tool pushing a container image to a registry. Instead of baking a password or API key into its image, the application authenticates to the vault using its own identity, such as a workload identity, a service account, or a short-lived bootstrap token. The vault checks the policy, decides whether this instance is allowed to request that secret, and, if so, returns the value over a secure channel. The application then uses the secret for as long as it is valid, but it avoids copying it into logs, metrics, or ad hoc debug output. Configuration management and orchestration tools can follow the same pattern, fetching secrets at deploy time or startup instead of reading them from static files. This is a mindset shift. Rather than treating credentials as configuration that rides along with the code forever, you treat them as live, managed objects that the environment issues and retrieves on demand. Rotation and revocation complete the picture. A mature secrets management practice automates key and password rotation on a regular schedule and can trigger emergency rotation when there is a suspected leak or a change in risk. The vault or management system updates the value at the source, updates dependent systems or allows them to fetch the new value, and records who accessed what and when. All of this depends on some basic groundwork, a reasonably accurate inventory of applications, logging that can show secret usage and anomalies, and a willingness from teams to adjust old habits so that secrets are no longer scattered across scripts and configuration files. You can see secrets management at work in many everyday workflows, even if nobody uses that label. When a developer wires a microservice to a new data store, when a continuous integration pipeline deploys an application to the cloud, or when a support engineer uses an internal admin panel, credentials are involved. In an ad hoc world, those credentials might live in environment variables, shared text files, or private notes. In a managed world, they come from a known source, carry defined permissions, and have a clear life cycle. That shift from informal to deliberate is where a lot of risk reduction happens. One of the most accessible starting points is to address hard-coded secrets in source control. Teams can scan repositories for API keys, tokens, and passwords, then move those values into a dedicated secret store. Applications get updated so they read values from environment variables injected at deploy time, or they request secrets from the vault as they start. This change closes off one of the most visible leak paths and forces a bit of structure around who is allowed to create, view, or change sensitive values without requiring a complete redesign of the system. More advanced patterns go further and treat every secret as unique, short-lived, and tightly scoped. Instead of a single static database password shared by all instances of an application, the secret system can issue individual, time-bound credentials to each instance. For administrative work, teams can adopt just-in-time access, where a high-privilege credential is only generated after an approval step and is logged from creation to expiration. As these patterns spread, they enable clear answers to questions such as who used a given secret, what they accessed, and when that activity took place. When secrets management is working well, one of the biggest benefits is a smaller blast radius when something goes wrong. A leaked key or password is less likely to grant broad, long-term access because its permissions are limited and its lifetime is short. Rotation can be done quickly and predictably, which reduces both the technical impact and the human stress of an incident. At the same time, hygiene improves. Secrets are less likely to show up in screenshots, personal notes, or casual tooling because there is a known, safer way to work with them. Another important benefit shows up in operations and audits. A consistent approach to secrets means there is a clear record of who issued a credential, which systems used it, and when it was last rotated or revoked. When an incident or compliance question arises, teams can lean on those records rather than guess or chase tribal knowledge. Investigations become faster and more grounded in evidence. Over time, this reduces the amount of energy spent on tracking down mystery passwords and trying to infer which keys might be related to a particular system or event. Those gains are real, but they come with trade-offs. A vault or centralized secret store becomes a new critical system that must be designed for availability, performance, and security. Teams need skills to define good access policies, integrate applications without breaking deployments, and monitor the health of the secret's infrastructure. If the system is slow, unreliable, or hard to understand, people will be tempted to work around it. Secrets management also has limits. It will not fix a compromised endpoint that can legitimately read secrets. It does not replace identity governance and role design, and it cannot rescue an application that ignores basic principles like least privilege. Because of these limits, it helps to look closely at how secrets management can fail in practice. One common failure mode is partial adoption. A vault is deployed, a few flagship services use it, but most secrets still live in source control, configuration files, or old automation scripts. Another red flag is long-lived, shared credentials that are never rotated because doing so would be painful or risky. In those situations, a single leaked secret can still reach many systems and accounts, and nobody can say confidently who might have used it. Process issues are just as dangerous as technical gaps. If onboarding a new application into the secret system requires a maze of tickets, manual copy and paste steps, or undocumented environment variables, teams will find shortcuts. That is how shadow secrets management emerges: passwords in personal password managers, private note files, or impromptu scripts managed by a single person. When ownership is unclear, and no one is explicitly responsible for reviewing and cleaning up old secrets, those shortcuts harden into a parallel, informal system that the official tools never see. Healthy secrets management looks very different in daily life. New applications are designed with a clear pattern for obtaining and using secrets from the beginning, and that pattern is documented and repeatable. Teams can point to a single place where each API key, token, and password lives, explain who is allowed to access it, and show how often it is rotated. Over time, scanning tools find fewer hard-coded secrets, and when an incident hits, rotation and revocation can be scripted or orchestrated without breaking core services. You also see strong hygiene around the end of a secret's life. When a system is decommissioned, its credentials are revoked as part of the shutdown checklist instead of lingering in vaults and configuration files for years. Reviews of secrets usage, whether formal or informal, are a normal part of work rather than a special project. Perhaps most importantly, developers and operators view the secrets process as predictable and workable. They may not love it, but they recognize it as the default path rather than an optional add-on, which is often the best sign that the practice has taken root. At its heart, secrets management for API keys, tokens, and passwords is about acknowledging that the credentials which power your systems are as important as the systems themselves. By giving those secrets a secure home, tying them to real identities and roles, and managing their full life cycle from creation through rotation to retirement, you reduce both the chance and the impact of misuse. The goal is not perfection. The goal is to make it much harder for a single mistake or leak to turn into a wide-ranging compromise. As you think about your own environment, certain patterns may stand out. Keys checked into code, shared administrative passwords, tokens that nobody can quite trace back to their origin, and manual processes that feel fragile. Those are not signs of failure so much as they are a roadmap. Each one points to a place where a more deliberate approach to secrets could narrow risk and make daily work less brittle. Moving along that roadmap step by step is what practical secrets management looks like in the real world.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.